Welcome everyone to your very first day at Cloud Bridge Tech Labs. Today, we're embarking on a journey into the absolute bedrock of modern tech. We are going to master Linux. Get ready, because by the end of today, the command line isn't going to look like some messy screen of hackers' text. It's going to be your single most powerful tool.
So, consider this your official onboarding. If you're ready to level up your engineering skills and officially join our DevOps crew, make sure to like and subscribe to this explainer so you never miss a training session. We've got a lot of ground to cover to get you production ready, so let's get right to work.
Here's our bootcamp itinerary for day 1. 1. The Linux file system. 2. Important directories. 3. Essential commands. 4. DevOps troubleshooting. 5. Linux permissions. And 6. Modifying access.
All right, Section 1. The Linux file system. Everything is a file.
Okay, so here's a mind-bending reality that honestly catches a lot of beginners completely off guard. In Linux, absolutely everything is stored and treated as a file. Literally, everything. It doesn't matter if it's a standard text document, a running piece of software, or even a physical piece of metal and plastic plugged right into your motherboard. To the Linux operating system, it's all just a file that can be read from, written to, or executed.
To give you an idea of just how far this concept goes, hard disks, they're files. USB drives, files. Running system processes, and even the network sockets connecting your server to the internet, you guessed it, all files. This is actually a beautiful kind of simplicity, because once you learn how to manipulate a standard text file in Linux, you basically know how to manipulate the entire computer.
Section 2. Important directories. Mapping the system.
Think of the Linux directory structure like a massive, highly organized city. Right now, I'm handing you the zoning map. At the very top, you have the root directory, which is represented by a single /. That's the city limits. The whole shebang lives inside there. Want to go home? You go to /home. That's where the user directories live. Need to change how the system behaves? Head over to /etc. That's your configuration district. Then you have the /var directory, which is where logs and variable data are constantly generating traffic. /temp is exactly what it sounds like. Temporary files. When you need your core tools, you look in /bin for your essential commands. We've also got /opt for optional software, /dev for those device files we just talked about, and /proc to actually peek at live system processes. If you type cd/etc and then ls, it's like you're literally walking into the configuration district and looking around at the files governing your system.
Section 3. Essential commands. Navigating Linux. So, the two most fundamental actions you're going to take in Linux are looking around and moving. Now, ls is how you list files. It's kind of like turning on the lights in a dark room. You can use flags like -l for a detailed long list, or -a to show hidden files. On the flip side, we have cd, which stands for change directory. This is how you boldly walk into a new room. cd/var/log takes you straight to the log files, while cd/ is this fantastic shortcut that instantly teleports you back to your personal home directory.
Okay, let's decode something that usually looks like absolute gibberish when you're starting out. When you run that ls-l command, you get a string that looks something like -rw-r-r-. What on earth does that mean? Well, the very first dash tells us the file type. Then, that first chunk of letters, RW, are the owner's permissions. The next R'- is for the group, and the final R'- is for everyone else. Right after that, we see the user who owns it, in this case it's root, and the group owner, which is also root. Finally, we get the file size of 1200 bytes, the modification date of May 10th, and the actual file name test.txt. See? Suddenly that cryptic terminal text makes complete sense.
Of course, sometimes you're just going to get lost in the city. When that happens, just type pwd, present working directory. It tells you exactly where you're standing right at that moment. But what if you know what you're looking for, but have no idea where it is? That's where the find command is an absolute lifesaver. If you type find/-name ngx.conf, you're telling the system to start at the root directory and relentlessly search every single corner of the computer until it pinpoints that hidden configuration file.
Section 4. DevOps troubleshooting. Production scenarios.
Picture this. It's a super busy Tuesday. You just pushed a major update, you deployed the application, and bam, it fails. Alarms are going off everywhere. What do? Do you panic? Make wild guesses? No way.
You're a professional. You rely on the exact basic commands we just covered. You're going to follow the exact steps of a true incident response. Step 1, deploy application. Step 2, app fails. Step 3, you dive straight into the logs. By using the command grep error/var/log/app.log, you instantly scan through thousands of lines of log data to hunt down exactly where that failure happened. Grep is incredibly powerful. It searches for specific text inside a file, isolating the needle in the haystack in literal milliseconds. Guys, this isn't just theory. This is real, in the trenches, production troubleshooting.
Section 5. Linux permissions, multi-user security.
Now, fixing an app is one thing, but keeping the server totally secure is a whole different ballgame. The absolutely crucial thing to remember is that Linux is inherently a multi-user system. You might be sharing the server with dozens of other developers, automated services, and background processes. Without strict rules, it would be total chaos. So permissions act as the VIP access badges of your operating system. They protect your everyday files, ensure critical applications aren't tampered with, and lock down sensitive data from prying eyes.
Let's break down how these access badges actually work. There are 3 basic permission types: R for read, W for write, and X for execute. And these apply to 3 different user types: the owner of the file, the group assigned to the file, and others, which literally means anyone else on the system. If we look at the example RWX-R-X-R, we can map the whole thing out. The owner gets the first 3 slots, RWX. That means they can read, write, and execute. The group gets RX. They can read and execute, but notice that dash? That means they absolutely cannot write to it. And others? They just get RWR, so they can only read. It's a highly granular, perfectly logical system once you see the matrix.
Section 6. Modifying access. Taking control.
I want you to burn this magic number into your memory right now. 755. You are going to see this everywhere in your Linux career. But it's not just some random code. It's actually a mathematical breakdown of access rights. Here is how the math behind chmod 755 brilliantly comes together. When you use the chmod command to change permissions, you can use numbers instead of letters to speed things up. The number 7 means RWX, full access. The number 5 means R-X, read and execute. And the number 4 just means R-, read only. So, when you type chmod 755, you are assigning the 7 to the owner, the first 5 to the group, and the second 5 to others. You're granting the owner full read, write, and execute rights while everyone else can only read and execute. It's quick, it's elegant, and it's totally secure. Now, it's absolutely vital we clarify a distinct difference here. You'll primarily use 2 main commands for access, chmod and chown. Chmod, as we just saw with chmod 755 script.sh, changes the permissions. It dictates what users can do with a file. Chown, on the other hand, stands for change owner. A command like chown ubuntu developers app.txt actually changes who owns the file. In this specific case, we transferred ownership to the user Ubuntu and the group developers. Basically, one changes the rules and the other changes the ruler.
Let's look at one final real-world scenario. Your application cannot start. You check the terminal, and you're hit with that dreaded permission denied error. Why did that happen? Well, because the script that starts the app is just sitting there as a plain text file. It doesn't have the VIP access badge to actually run. The solution? You just run chmod +x start.sh. That +x explicitly adds execute access, instantly fixing your broken deployment and bringing the whole system to life.
All right, team, that officially wraps up the theory for day 1. But now it is your turn for some interactive practice. I want you to open up a terminal right now. Use the touch command to create a brand new file called test.txt. Then use chmod 777 test.txt to completely open up all permissions for everyone. Finally, run your ls-l command to verify that those permissions have actually changed. Seriously, get your hands dirty. You have successfully mapped the directories, mastered the essential commands, tracked down errors, and learned exactly how to control access. Now that you hold the keys to the Linux file system, what are you going to build first? Think about it, run those practice commands, and I'll see you right back here for day 2.